Okay, quantitative analysis of compounds. We'll get into this. Some of these, again, unless I feel it's necessary, you will answer the questions and watch the videos and stuff on your own. And that way you'll be able to figure that out on your own. But let's see. This is just to give you a better understanding of things going on, the definitions, stuff like that in the videos. A lot of times I've done mini lessons on a lot of the stuff in here, and this is just a basic overview of everything. Okay. So I have a periodic table up here. This comes in handy because you can click on an element and you can learn all about it, from the history to the properties to everything like that in here. So if you haven't already bookmarked this website, I would do so because it'll come in handy when you are learning about the periodic table, chemistry, all that fun stuff. Significant figures. This gives you a breakdown of significant figures, and you have addition, subtraction, let's see, multiplication and division. So if you've looked at some of my other mini lessons, I have broken it down for you about significant figures. It does like step by step to make it a little bit easier. You have addition, subtraction, multiplication, and division, and I show you the process of how to figure it out. Because it can be a little bit tricky, but I keep it simple with that. So, and there's another mini lesson I have. I recommend you refer back to it because it shows you how to calculate significant figures and how to figure it out. Okay. So there's a lot in here. I won't go over the questions. I'll let you just do those on your own. We'll skip the video too. Percent composition. Let's do this first. Let me read you the definition. The percent by mass of each element in a compound. Now, let's read this. So a mixture, 10 cashews, each weighing 2 grams, 10 almonds, each weighing 0.5 grams. Total mass of the mixture is 25 grams, and there's, let's see, 50% of each. So 50% of cashews, 50% of almonds. However, the number of cashews, the percent composition of cashews is 80. And why is it 80? Well, because the cashews are heavier than the almonds. Cashews weigh 2 grams, almonds weigh 0.5 grams. Therefore, it will take up more of the percent composition because they are heavier. Again, my significant figures. This cheat sheet here and identifying is great, but I recommend you refer back to the other videos because it will tell you exactly how to solve it, and it gives you an example. Because it's like chemistry and algebra kind of intertwine and connect with each other a lot. Can be confusing. Molecules of water, that's the H2O, and that contains 3 atoms, 2 hydrogen, 1 oxygen. There. Now let's skip that video. And we'll skip that, just telling you how to solve the percent compositions. Now we have acetic acid. Vinegar, for an example, is a solution of acetic acid. Pretty interesting, isn't it? Here is our official chemical written down here. There's a carboxyl group. The formula, so here's our formula of acetic acid, is written as CH3COOH rather than C2H4O2. Why? Well, they want to emphasize the carboxyl group here, and that's why it is squared off carboxyl group. So carboxyl group is consisting of a carbon atom double bonded to an oxygen atom and a single bonded to the oxygen atom. So the carboxyl group is important, and that's why they have it written down like this, the formula for acetic acid. That's why it's written like this versus the other way, because we have the double bond of oxygen and the single bond there. Okay. So using the molar masses of carbon, hydrogen, and vinegar, the oxygen from the periodic table, you can figure out and calculate the molar mass of acetic acid, which again is part of vinegar. Now, so that's how you would figure this out. So then acetic acid is carbon, hydrogen, and oxygen, which is part of vinegar. So interesting that vinegar has all those in it. So then here's how you figure out the percent composition of acetic acid. The mass of acetic acid versus mass of the sample of the vinegar solution. So mass of acetic acid divided by mass of vinegar solution. And there you have it. There is the percent composition of it. Okay. So again, questions will let you figure that out. Empirical formulas. Chemical formula in which the subscript that represent the relative quantity of each element as the smallest whole number ratio of atoms. Okay, empirical means based on observations or evidence. All right, molecular formula versus empirical formula. As you can see, they're very similar with each other. They do have some stuff in common, however, they are different. Even though they do look very similar. Here's an example, nitrogen dioxide, dinitrogen tetroxide. As you can see, there's a double bond, single bond, and they're bonded differently with each other here. So that's why. Let's skip those questions here. This is just showing you empirical formulas from lab data, showing you the number of moles. These tutorials often refer back to this periodic table. I still recommend that you click on it and you are working in the periodic table. And again, definitely bookmark it because as you can see, it's in a lot of the slides. You will need to go back to it often. So again, we'll let you answer these questions. Molecular formula is a little bit different. The molecular formula of acetic acid is C2H4O2. So it is a little bit different. They have it written that way versus the other way that you saw. And here's formaldehyde. It's CH2O. So let's see, molecular formula, empirical formula. So this just shows you, here's the formulas, here's the weight. And here's our equation, molecular weight divided by empirical weight, kind of averages out. Let's go to, and that would help you find the, right here. Okay, we'll let you answer these questions. So molecular formula from laboratory data and identifying a substance. So here's a question. It'll have you calculate some things in the periodic table. So again, you will need to use that periodic table to calculate the answers here. And let's see, we'll just have you answer those on your own. Careers in science. Now the ending of the tutorial will give you some examples of careers in science. Shows you engineer, pharmacist, physician, patent attorneys can be considered careers in science. Chemist, that's another one. Now it just will briefly go over like types of careers in science and it'll show you a little job description about it and what they do. So then we have analytical chemist versus physical chemist, and I'll just tell you this, I will show you this question. Analytical chemist measures quantities of substances in a mixture, identifies composition of compounds. Physical chemist develops new compounds and researches the behaviors of compounds. And then again, you'll definitely need to refer back to the periodic table. And there you have it. Quantitative analysis of compounds tutorial. And that is the ending of it. And yeah, hopefully that gives you just a better understanding of everything.